Okay, so you have to verify this using the index notation. So can you guys work on this? Let's say you write the index notation for the left hand side and then try to get back the right hand side. So this A cross B dot C cross D, how will I write? Can someone tell me the index notation for this? A cross B dot C cross D, anyone?
AI BJ epsilon I
AI
BJ
BJ
epsilon IJK
epsilon IJK.
EK vector EK unit vector
Okay. Mhm.
dot CLDM epsilon LMN dot unit vector EN.
Then okay, if can you further simplify this?
I think we will get delta Kn, sir, in the next expression.
Okay. CLDM delta Kn, right? And then
Sir,
I can write
epsilon LMN will be there, no, sir?
sorry. Epsilon IJK CLDM and then Kn, right? So let's say LMK, right? Acha, I can skip these two steps, right? And I can directly write this one as C. A cross B, I can write in shortcut epsilon IJK AJBK, right? And this is getting dotted with C cross D. So the the free index for this A cross B is what? So free index is I, and this is getting dotted with C cross D. So I'll be writing epsilon I L M C L D N. I can write like this. So the free index of this has to be same as the free index of this, right? Because there is a dot product. So a dot b is what? AI bi. So there is a repetition of index. So similarly, epsilon ijk ajbk epsilon ilm cldn. So this, right? So this is what? AI bj epsilon I jk, and then it's epsilon lmk cl dm, right? Or I can write like this: ai bj epsilon kij and then epsilon klm cldm. So this one and this one, they are same, both are same, hai na? So instead of writing all the intermediate steps directly, I can write this one, right? So okay, now I further simplify this. So let's say I'm using this. Only the difference is like it's aibj and then epsilon kij. Here it's ijk and then ajbk. Only the change of the index. Otherwise it's same. I mean all the indices are repeated, right? I is repeated, j is repeated, k is repeated. So all of them are dummy index. All of them are dummy indices, है ना? So it doesn't matter. Okay, now I simplify this as okay. So I have epsilon ijk epsilon ilm, right? So this I can write as delta jl times delta km minus delta jm times delta kl times ajbkcldn. Right? And then delta JL delta KM AJ BK CLDN minus delta JM delta KL AJ BK CL, and this is NM, right? This is M. Okay. Praveen, Praveen, can you simplify this? Praveen, Emmanuel, Pratish, Rubel, Devrishad.
Yes, sir. First, we have
Simplify
to drop
this.
this. First,
You
we
have to
have to
simplify
drop
this.
delta JL, then delta KM,
Hmm.
then delta JM and delta KL. J is replaced by L.
So tell me the simplified term,
Okay, sir.
simplified
Sir, I'm
first term.
doing.
Hmm.
The first term will be AL, BM, CL, DM.
AL,
BM,
BM,
CL,
DM.
DM.
Right.
Sir.
In second term,
AM, BL, CL, DM.
AM,
BL,
BL.
CL.
Okay. So now write the Gibbs notation for this. So what will be the this term? So I have AL, BM, CL, DM. This I can write as AL, CL, PM, DM minus AM, DM, BL, CL. Now write the index notation for this. So the index for A and C are same. So what does it mean?
A dot C.
A dot C, right? Okay. And then we have
Then B
the
dot
B
D.
index for B and D are same. So it will be
B dot D.
B dot D minus.
A
What
dot
about this
C,
one?
B dot C.
A
A
dot
dot C,
D,
B dot C.
B dot C, right? So which is your right hand side, right? So this is how we can verify using the index notation. Okay. Last class we were discussing this del, right? So we have seen gradient, we have seen divergence, we have seen curl. So Prabin, can you tell me what is divergence and curl? Praveen, if you don't
Yes, sir.
respond,
Yes,
right?
sir. So divergence is the del operator of the some scalar quantity. That is the del dot some scalar function is the divergence, and
How will
del
you find
cross.
del dot scalar function?
No, sir. So sorry. The del of some scalar product is the divergence, and the del cross some vector product is the curl curl of that vector.
And what is gradient then?
Like
Gradient.
gradient. Gradient. I think that the del operator of the scalar is gradient. Sir, I don't know
Right.
about.
So when del operates on a scalar function, it's
Yes,
called
gradient.
gradient.
Yes, sir.
And when del operates on a vector function, right? So in a vector function, we have so gradient is del operating on a scalar function. And this divergence is what? When del operating on a vector function via dot product, and curl is what? When del operating on a vector function via cross product, right?
Yes, sir.
And in index notation we write this like partial it, this is partial ivi, and this is epsilon ijk partial ivj. This is the index notation, you know. Or I can also write partial t by partial xi, or partial vi by partial xi, and or epsilon ijk partial vj partial xi. Okay, so these are the index notation for divergence, curl, and gradient, and we have seen double derivatives also. Okay, so today we will do some exercise, right? So ठीक है चलो I'll okay. So again you have to verify this. Del dot A cross B is equals to B dot del cross A minus A dot del cross B. Okay, so can you verify this? So just write the index notation for this. Left hand side, very okay, rearrange or simplify the expression, and then try to get the right hand side. Write the notation for that simplified term, and try to get the right hand side. Okay, so okay. So this I will write as partial I, okay, and this is getting dotted with A cross B. So A cross B is epsilon, okay. See, the first index is, let's say, the index for the resultant vector, and since it is getting dotted with del, so the index will be same as the index for partial because it's getting dotted with del. So epsilon I j k aj bk, right? And then I can write epsilon ijk. So see, this is del operating on this del operating on this, right? And epsilon ijk, it's a constant, it's 1 minus 1 either 1 or -1 or 0, right? So I can move this epsilon ijk out of the derivative sign. So epsilon ijk partial I aj bk, and then this can be written as, see, this is going to be, when I expand this, right, it will be what? Epsilon ijk partial I aj and b at the front plus a at the front partial I bk, right? And if I expand this, it will be epsilon ijk bk partial I aj plus epsilon ijk aj partial I bk. Okay, now can you write the Gibbs notation for this? So have epsilon ijk partial iaj, right? So if I take these terms, right, it will be what? Epsilon ijk partial I aj, right? So I is appearing before j, so it will be del cross a, right? And then this k, the index k and index k here is same, so this whole thing is getting dotted with b plus this epsilon ijk partial I bk. So see, ijk, I is appearing before k, so it's ijk, right? So I can, sorry, ijk, yeah, so I can write this as jki, right? Which is same as epsilon ijk. So and k is appearing, sorry, I is, j is, just a minute, epsilon ijk. Okay. If I move I, yeah, so acha, this is what? Epsilon ijk, right? Acha, one thing here. There is a, this is meaningful, right? But A cross del, it's not meaningful. Right, so I have to write this one as minus, let me write here only, minus epsilon ikj aj partial I bk. So ikj, no, I is appearing before k, so it will be, this will be del cross b, and j here and j here, it's same, so the resultant vector is getting dotted with a, so I can write this as a dot del cross b. Acha, whether I am writing a dot del cross b or del cross b dot a, both are same, right? Because a dot b is same as b dot a, so it doesn't matter. So this I can write as b dot del cross a minus a dot del cross b. So which is my right hand side. Is this clear? Right, so del cross a, it's not meaningful, right? Sorry, it's del cross, normally we write del cross a, so del operating on vector a via cross product, but a cross del, if you don't have in the right hand side, then it's, there is no meaning of such expression, and there has to be something on the right hand side of your del, either del times scalar function, that will be gradient, or If it is a vector function, then there will be either a dot product or cross product. Okay? Or a dyadic product. So dyadic product I'll explain later. But so there has to be something on the right hand side. Okay? There is no meaning if you don't have anything on the right hand side of your del. Okay? So this is how we how we can show this, verify this using index notation. Okay, so this is nothing but right here, I mean this one, product rule. A times B is what? A times partial B by partial X plus B times partial A by partial X. This is same, है ना? Okay. Acha. So till now we have seen the index notation for a vector, right? For a second order tensor, right? Let's say capital T or tau. So second order tensor means there will be two bars, right? I mean, so in vectors there will be just one bar or one arrow. In second order tensor there will be two, and in index notation we write epsilon person summation ij tau ij and then ei ej. There is nothing between this ei and ej, so this ei and ej, it's called unit dyad, right? And it's a dyadic product of ei and ej. So v times v, right? It's a dyadic. So when there is no symbol between two vector functions, right? So in cross product there will be cross, in dot product there will be dot. But well, let's say when there is no symbol, that means that you are looking for the dyadic product of those two vector functions. So ei ej is a unit dyad, and it's a dyadic product of ei and ej. Okay, so okay, so mathematically, right? Mathematically, how we represent tensor, second order tensor, by a matrix, right? So tau is represented by, mathematically it's represented by a matrix. Tau xx, tau yy, sorry, tau xy, tau xz, tau yx, tau yy, tau yz, tau zx, tau zy, tau zz. So mathematically we represent it by a matrix, right? Okay, so this index notation, tau is tau ij, right? So we can, while writing the index notation, we can drop the summation sign as well as the unit dyad. So it can be written as simply tau equal to tau ij. That is index notation for second order tensor. Third order tensor, epsilon ijk ei ej ek. It's a unit triad. Okay, so but normally in fluid dynamics, right, we see only either first order tensor, which is a vector, or second order tensor, or zeroth order tensor, which is scalar. Okay, we rarely see third order tensor. So with third order tensor we see in cross product. I mean, only the third order tensor we see is this epsilon alternating unit tensor, which is, so epsilon is one. I mean, so we know that property, right? If it's for cyclic combination of ijk, it's 1, non-cyclic it's -1, and otherwise if any of the two index is repeated, then its value is 0. Acha, for this tensors, right? So let's say I'm writing a dot t, right? So in index notation it can be written as ai tjk, and let's say I'm writing the unit vector, so it will be ei dot ejek, right? So in that case it will be, so this will form delta ij. Okay, so it will be ai tjk delta ij ek, and then I can drop this delta ij. So in this expression I have to replace either I by j or j by I. So it will be ai tik ek, or simply ai tik, right? So the idea is, see, this is AITIK. So when I'm writing AITIK, so whenever there is a dot put, right, that will be, there will be repetition of the index. So AITIJ, A dot T will be AITIJ. So the index of A and the first index of T is same. If it is T dot A, right, then can you guess what will be the index notation for this? Tij aj. So the index for the A will be, and the index for j and second index for the t will be same because it's t dot a. If it is a dot t, it will be ai tij. If t dot a, it will be tij aj. So we have seen, right, or we know that a dot b is same as b dot a, but a dot t is not same as t dot a. So you can check this, right? So a dot t is what? We have seen that it's ai tij, and t dot a is what? Tij aj. Okay, or let's say if I'm using the index a j, then it will be ij. Okay, so it will be like this. So acha, um, how to check whether they are same or not? I mean, they are different actually. See, this the in this quantity, right, aitij, the number of free index is what? Is 1, right? That means the resultant quantity is TD is first order tensor. If the resultant, if the free index is 2, number of free index is 2, that means that quantity is second order tensor. If the number of free index is 0, that means the resultant quantity is what? It's a scalar quantity. Okay, so the number of free index is 1, that means it's a It's a vector. Okay, first order tensor, which is vector. So AI Tij. So if I expand this, right, it will be what? See, it is AI Tij. So the repeated index is I. So that means for a given value of j, you have to find the sum for all possible values of I. So if I expand this, right, it will be like this: A1 T11 plus A2 T21 plus A3 T31 times E1 plus A1 T12 plus A2 T22 plus A3 T32 E2 plus A1 T13 plus A2 T23 plus A3 T33 E3, and this A AJ Tij, it will be what? A1 T11 plus A2 T12 plus A3 T13 E1 plus A1 T21 plus A2 T22 plus A3 T23 E2 A1 T31 plus A2 T32 plus A3 T33 E3, right? So for this, the component in direction 1 is this much, and for this quantity, the component in direction 1 is this much, right? So it's A1 T11 plus A2 T21 plus A3 T31. This is A1 T11 plus A2 T12 plus A3 T13. So these two things are two different quantities, two different vectors, right? Did you get my point?
Yes, sir.
Uh, is this okay with everyone? Any confusion? Anything you want me to explain once again? ठीक है. अच्छा. What about the dot product? Let's say I'm finding A cross T. Can someone tell me the index notation for this? Result and index notation for this, you can try. Anyone? So this I can write as AI Tjk. They are scalar component, right? So I can move them at the front, and then I cross Ej Ek. So this is going to make epsilon Lij Lek. Right. So, or I can simply write this as epsilon Lij Ti, sorry, Ai okay, let I've dropped the unit diode. So this is my final quantity or the final expression, epsilon Lij Ai Tjk. So can you tell me what is the order of this resultant quantity and what will be this a scalar, a vector, second order tensor, third order tensor? Anyone? How many free index here?
Two, sir. Two free index.
Equals to what are those free index
L and K.
indices?
L and K, sir.
L comma K, right? That is two numbers. So that means it's a second order tensor.
So,
Right? So it's a tensor. A cross T is, so when you find a vector cross second order tensor, resultant quantity is also a second order tensor. Acha, so to find the order, right, we have another uh, the easy way to to tell that what is the order of resultant quantity. So when you're finding the dot product, right, you do this sum minus 2. So sum is sum of orders, sum of orders. So sum of the orders of the participating quantities. So let's say you are doing this a dot b, right? So sum will be what? 1 plus 1. So a is a vector, so order is 1. B is a vector, so order is 1. So sum equal to 1 plus 1. So the resultant quantity order of the resultant quantity equals to 2 minus 2 equal to 0. That means scalar, right? A cross product, we have to do sum minus 1. Okay, dyadic product, you have to do some minus 0. So cross product, right? So A cross T, sum equals to how much? 1 plus 2 equals to 3. And then you have to do 3 minus 1 equals to 2. So the resultant quantity is of second order. That means it's a second order tensor, right? And in dyadic product, you have to do sum minus 0. So when I say dyadic product, right? So let's say I have this AB or VV, or let's say I have a quantity something like this del V. So this is dyadic product of A and B, dyadic product of V and V, dyadic product of del and V. So it's a, all of them are second order tensor. ठीक है? Okay. Okay. Uh, okay. In the similar Acha, not this, this, the resultant of the order of the resultant quantity. Just few more things. Can you check this? So I have A cross B, right? Sorry, A cross B, not A cross B. Okay, so I'm doing this T cross A. So we have seen A cross A dot T or T dot A, right? We have seen that components are different. Can you do this? So this you can take this as homework, right? So T cross A and A cross. Huh. So they are different. I mean, write all the components and so they are different. So T cross A, the resultant quantity will be how much? It will be a second order tensor, right? So second order tensor, that means it will be, if mathematically you have to can present them by a matrix, right? So you have to make this matrix and show whether they are different or not. Okay, the same means all the components will be same, different means the components will be different, right? If any one of the component is different, that means those two second order tensors are different, right? So this you can take as a homework. Okay. Acha, okay, I'll just summarize. I'll just write couple of points about this index notation, है ना? Some can say it's called be rules. First, any letter can be used for the index on vector. Used for the index. The second rule in an equation, all the quantities or all the terms I should write. Should have the same free index and they should be of same order. So like, can let's say I have term AI BKK plus SLM HLMI equals to CI, right? So this one is correct because the number of free index is 1 in all the terms, right? And the free index is I in all the term. And let's say I have a term AI BKK plus SLM HLMJ equal to CP. So this is wrong, because it is P here, it is J here, it is I here. Okay, so this is wrong. And also the order of every term. Let's say this term is vector, right? So let's say this term is, let's say this term is a vector. This term has to be, this term cannot be scalar. Okay, and this term has to be vector. Okay, so I mean you can add vector in, you can add vectors in vector, right? I mean you can add two vectors, but you cannot add a vector with scalar, or you cannot add vector with a tensor, second order tensor. So that's what I mean by saying they should be of same order. Okay. Okay, third one. Unrepeated index or free index is the fundamental direction. Is the fundamental direction. Okay, and index repeated, that shows dot product. Okay, and last one, you cannot have the same index more than 2 times. You cannot have the same index more than 2 times. Okay. You cannot have more than same index more than 2 times. If any index is appearing thrice, that means uh, you're doing some mistake at any step, or maybe, I mean, you need to check your expressions. Okay. Uh, any index cannot appear more than twice. Okay. So these are the few things about the index notation. I guess, yep, we are done with it. Any question on index notation? I'll share, there are a couple of set of notes, and I'll share in that MS Team, in that page. I'll, in that files tab, I guess, I'll share those notes. Hai na? Okay, anything you want to ask about index notation, anything which is not clear, or anything which is troubling you, bothering you, anything? I'll give you one assignment on this, so that will help you to understand index notation. Okay, so you can do some practice and then it will be handy. Okay, so we'll just take the attendance and then you can leave. Okay, guys, you can leave now. If you don't have any
Thank you.
question, you can leave now.